Okay, students. So we have the topic, the potential energy of a spring. I told you that in your book it is written as V. So V or U, we will use the symbol U, okay, because this is used more frequently. So that's the same thing, okay, U. So potential energy of a spring. Good. Let us recall some concepts. F of x is equals to minus dv, so it's du we are taking. This is rate of change of potential energy with respect to displacement. Okay. See, what is the importance of this? This is x axis, and on the y axis I have u. So u. So this is your function, students, u, and u is a function of x. Do you remember? What is the meaning of df of x of dx? This means slope function. Of what? Slope function of f of x. Right? So after derivating this, sir, give one example. Okay. D by dx of x square. This is my f of x, x square. Now, differentiate it. So 2 will come in front, power will come in as coefficient, and power is reduced by 1. That is. So students, this was f of x. Okay. So f of x is x square here, right? So this is f of x, which is equals to x square. This origin plus x-axis minus x-axis, and you get this graph, parabola. F of x equals to x square. So f of x is on this axis and x is on. So what is this 2x? This is the slope function. This is the slope function. How do we write it? That is written as f dash x. So this is your function, and this is your slope function, f dash x. So either write it as df by dx or write it as f dash x. This, both of them means the same. Notation is different, they are same thing. So means at any point, like this x is equals to 1. So what is the value of the function at this point? So value of the function at this point is 1, 1. What is the value of the function at x equals to 2? So it is square of 2. So 4. What is the value of the function here at x equals to minus 1? It's minus 1, 1. And at minus 2, this point on the curve, minus 2 and 4, because square of minus 2 is 4, square of plus 2 is also 4. So this is my function f of x. Now what is this 2x at any point, students? The slope here is 2x. So 2x is 2 into 1 is 1. What is slope here? The slope is increased. 2 into, what is x? X is 2, 2 into 2. So slope is 4 here. What is the slope here? This is negative slope. Put x equals to minus 1. So here put x equals to 1. So the slope was 2. Sorry. Here put x equals to minus 1. What is the slope? Minus 2. Here put x equals to minus 2. At this point, what is the slope? Slope is equals to, this slope is minus 4. So this slope is negative slope, and this negative slope minus 4 suppose, and this positive slope. plus 4. So students, I hope you have understood what is the meaning of this differentiation. So you are doing it same. You have replaced f of x with u of x. So instead of f of x, you have u of x. So you will also have a graph of u of x versus x. And so you have these graphs in your question also. Exercise question 6.3. That's the same graph you have. So this is potential energy function. What do we call it? Like this was parabolic function, and this is potential energy function. Okay, so that's your position. Now when you will draw a graph of this, we have this graph as in figure 6.8 also in your book. So exercise question 6.3, figure 6.8. So that is why I was not going to this question 6.3, because unless and until you understand this concept, how can we go over there? And still, before taking that example, exercise question, I need to teach you the potential energy functions more in detail. Okay. Now this energy curve in figure 6.8, you can see that that's the maximum energy. So this is the curve of u of x. So this one was kinetic energy. Potential energy curve was, this is the potential energy curve, u of x. Figure 6.8, page number 124. So there are three curves. Take the one which is of potential energy. So now at any point on this curve, this slope is your f of x. This slope is your f of x. So that is the meaning of this equation. What is f? What is the force? And this conservative force. So I told you that the conservative force is changing at every point. So it is just like your parabola. This is parabola, yes. And you can see that its slope is changing at every point. Its slope is 2x. So it's changing at all the points. So conservative force, I told you that it's a variable force. It depends on x. So students, this force is the slope of this graph. So u of x is the graph. When you write d by dx, it means the meaning of this is slope. Okay? That's the meaning, this slope. Now, the important thing is that see here, f of x is equals to minus, so taking a short displacement, suppose let us take here to here and then here to here. Okay, so this will be delta u by delta x. So that's what, now this delta x, we can write it as f of x delta x is equals to minus. So when I will keep on adding this f of x delta x, so it will be like f of x, adding all of them, xi to xf, means all of this, the work done by the force. So this delta will change into dx again, and this is delta u, and this will again be integrating both sides. So integrating both sides, this will be du and initial to final, and this will be equals to, I told you that this is x into dx, so its derivative is, means this is xi, this is xf, no, not x dx, but only dx, only dx, only du. So only dx, so its integration is x and then xi to xf, and that's equals to xf minus xi, and that's equals to delta x. So students, directly you can write this to this, okay, you need not to write the intermediate steps. So that's equals to minus delta u, okay. So that's the work done by the conservative force. So adding up this change in, so total work done is equals to change in potential energy. Now write one important line here. Conservative force, very important line, very important, most important. Conservative force always act in the direction of decreasing potential energy. This is, what does this mean? That the work done will be negative, work done is in the direction of decreasing potential energy. Let us take one or two examples. This is our earth. I have a ball over here. So this ball at this point, this is at height h. Now leave this ball free, what will happen? It will come down. So Fg is acting downward. So here what was the potential energy? mgh. Here what is the potential energy? 0. So what this force has done? This force acts in the direction of decreasing potential energy. So in this direction potential energy was decreasing. Okay. Now let us see one more example. This positive charge, and I brought some positive charge from here to here. So now what will happen? Leave this charge free. So I have done the work by applying the force and bring it here. So potential energy is stored in it. As you leave this charge will move back. So electric force was acting to decrease the potential, and it will keep on acting, okay, until this whole potential energy will be converted into kinetic energy, and at infinity this potential energy will be 0. So see how we define potential energy. Here we are defining that potential energy on the ground is 0. Here we are defining that at infinity the potential energy is 0. So it is up to us where we are defining the potential energy to be 0. Okay. So students, this is what all this concept is about. So this is V final minus V initial, and that can be written as Vi minus Vf, but that's the main thing. Now let us look at this formula again. F of x is equals to minus du by dx. Let us apply it for the gravitational force, and let us apply it for the spring force. So we are doing the spring force. So I've drawn it over here. Let us see what this spring force is. Let me bring it. No. Okay. Students, this is x equals to 0. I have a body over here, and this is equilibrium position. This is equilibrium position. Now I have stretched this spring. So tell me, in what direction the force is acting on this spring now? Spring force. This spring is, you are pulling it on this side, but what is the direction of the spring force? This direction. This is the direction of the spring force. And you are taking this direction as positive. So this direction will be negative. So Fs is negative. And x is positive. So this x is positive because it is acting in this direction. And spring force is opposite to the direction of the displacement. So Fs is negative. Now, you have compressed this spring this time, compressed. So in which direction this spring force will act? Obviously, spring force will act in the positive direction. So that is why this direction is positive. It is moving in this direction, positive direction. So that is why Fs is positive, but displacement here, you have moved from here to here, so displacement is negative. So x is negative here, whereas Fs is positive. So you have seen, students, that the spring force is always, see, if you have stretched this much, Fs is less. Stretch it more, Fs will more. So it depends on the displacement, and it is in both the r vectors. So if they are in opposite direction, I need to put here negative sign. So that's the case. Fs is directly proportional to negative x. And let us replace this constant of proportionality with the spring constant, that is k. So Fs is equals to minus kx. So that is Hooke's law. That is Hooke's law. Now we know the formula. You have just did that that F is equals to conservative force into dx. So let us apply the same formula here, because that was for general case. So now what will be the work done? So work done will be Fs into dx 0 to xn, and that's equals to, so what is Fx minus kx into dx 0 to xn. What is this 0 to xn? So it was 0 over here, and the maximum I have stretched it up to here, so I will call this xn. Here I have stretched it up to here, I will call it minus xn. Okay, so once I have stretched it here, so the work done by the spring force will be negative, because displacement is in this direction and spring force in this direction. So that is why work done you will find negative. Students, see, very important thing I am discussing with you, that Don't go by these variables. Your answer must be minus 6 joules, this is what I want, or minus 10 joules, this is what I want. Means the answer will be negative. This variable, they are not telling you, see here you will say, sir, it is positive sign. Here you will say it is negative sign. Yes. So what do you want? I want this 6 joule to be negative. I want this 10 joule to be negative. Unless and until you are sure about these variables. So what does this mean? It means a lot, student. We'll discuss it at some more point of time, but what I want to tell you is that I want it to be minus 6 joule. This value must be negative. This is what I want. So don't go by these variables, positive, negative sign. This is the ultimate thing that is needed over here. So you will ask me, sir, why haven't you put here negative sign? Because the displacement was in this direction and force is in this direction. So here also the angle is 180. Why you are not taking it negative here, cos 180? Why? Because I have taken that effect in Fs. That force and displacement are in opposite direction. So you cannot take that effect 2 times. So I have taken that effect in the force itself. Okay? This force is opposite to the displacement. So that impact I have taken over here. So students, this thing you need to understand and remember. Okay? Good. Now, what is the integration of minus kx dx? So x dx, you know that this is equals to x square by 2. So constant will come out minus k, and x dx is x square by 2, 0 to xm. Maximum displacement. So maximum you have stretched it up to here. So this is xm. And that's equals to, so half is constant minus k, and this is xm, put final value. So xm square minus, put 0, so that is 0. So that's your work done by the spring force. Now this was your, what was your Fg? Like here. So your Fg was minus mg, this direction you are taking positive, and this direction you are taking negative. So it's minus mg. Now Fs is equals to minus mg. You can take dx or you can take height. That's your displacements, what means delta h and dh. So small work you are doing. So this is the work done by the, not spring force, this is work done by gravitational force. So not S here. This is F. This is gravitational force, work done by gravitational force. So put the value of, so work done by gravitational force is equals to minus Fg into dh. Okay. So m and g are constant, they will come outside, and then you have the integration of h. So you have taken it to the height, suppose the body 0 to h. Okay, so this is ds, sorry. So this will comes out to be, so you have taken the limits 0 to h here. So minus mg, and dh is h, right? dh integration h and 0 to h, and this comes out to be minus mg, so h. So that's your work done by the gravitational force in raising this by the height h. and opposite to it is the work done by external force, that is mgh. So this is stored in the form of potential energy, and that is equals to minus u. Now if we are taking the limits, work done by gravitational force minus so again, as you are taking this effect, students, so negative will not be here, because s is equal to minus g. I am taking this impact over here, so that is why force was in this direction and height was this, but still I have taken them because I have taken this effect over here. Okay, now again fs to dh. Now suppose you are taking it from 0 to, this is minus h, suppose. Now 0 to minus h. So what will the work? Now the body is moving from 0 to minus h, means from here to here. So 0 to minus h, f of s, sorry, this is f of g. Yes, work done by gravitational force is the fg here. So the fg is minus mg into dh, right? But here the limit is 0 to h. So the body is coming down. So negative outside, mg, and this h will be here. But here now it's 0 to minus h. So put the value of final position, that is minus h here. So mg into minus h minus 0. So this mgh. So this work done is positive because you are doing it in the direction of the gravitational force. So student, this is what this all about. Okay. So you have studied the spring force. So that is why this case I have written. It is applicable for any conservative force. This work done is for any conservative force. So use it anywhere to try it out. Even so, because differentiation is opposite of integration. Okay. So if you want to find out f of x from du by dx, this work done is stored as in the form of potential energy, right? That's minus u, and now minus du by dx, that is what fx is. So what is u? U is this, right? So put the value of u, that is d by dx of half k xm square. So half k is constant. What is differentiation of xm? So negative will be there. Xm is 2xm. So this will be cancelled out, and that is equals to minus kxm. That is your force. That's where we started with. So differentiation and integration, they are opposite to each other algebraically. Okay? If you have done the integration of minus kx, this is what you get. Now doing the differentiation of it, you will go back. This is what this concept is all about. Okay, so integrating it and then differentiating it, go back. So you can say that integration is actually anti-differentiation, or anti-differentiation is integration. Both are anti. Integration means Geometrically it means finding the area between the curve and the x-axis. Okay, and this differentiation means slope, finding the slope function, and this is about the area. But algebraically when we solve it, they are anti. Like if you have d by dx of suppose x cube, what do you get? 3x square. Now do the integration of 3x square dx. What do you get? 3 is constant outside. What is integration of x square? That is x cube by 3. Plus constant of integration is also there, let it be 0. So that's equals to x cube. So started with x cube, differentiating it, it becomes 3x square. Now integrating it back, x cube. So that is why integration we call anti-differentiation. Okay, and their geometrical meaning are so different. It means the slope function, and integration means finding the area. Means if this is the curve, you are doing that, so adding this is your integration. So students, I hope that you have now understood this differentiation and integration. Now important thing is that we have a graph which is figure 6.7. So what this graph is about? What is it telling us? What is this graph between? So it is between fs and x. Okay. Now what is the formula you have? The formula you have is that f of s into dx. So if you have a graph between these two, then the area will be the work done by the conservative force, or it is also the potential energy stored. So this is your fs, and how will you, and fs is equals to minus kx. So minus kx, you can assume it as y is equals to mx plus c. This is the equation of a line in the slope intercept form. Right? So what is the slope here? Minus k. The slope is negative. Sir, what is the meaning of negative slope and positive slope? Okay. This is a line. Always, you have a bicycle all the time, okay? And you are riding the bicycle. So ride the bicycle from, how do you ride? You ride from left side to right side. So that is why always ride the bicycle from left side to right side. If your bicycle is going down, it means the slope is negative. If the bicycle from left to right, remember, left to right, if your bicycle is going up, then the slope is positive. Very simple terms I have explained you. And slope, it is change in y-axis divided by change in x-axis. So positive means, so this is y final minus y initial divided by x final minus x initial, and you can also write it y2 minus y1 upon x2 minus x1. You can also write it as y dash minus y upon x dash minus x. So this is what three notations you can take. So if this is yi, so it means if yf is greater, then xf will also be greater, then only this slope will be positive. So it means when you are moving in this direction, x and y, if x is increasing, y is also increasing. But in negative slope means x is increasing but y is decreasing. That is why this y of f will be smaller, so this will be negative, and x of f will be greater, so this will be positive. So negative upon positive is negative. So that is why we have negative slope over here. If both are increasing or both are decreasing, then it will be a positive slope. But if any one of them is decreasing, then it's a negative slope. And simple thing I have told you, ride the bicycle from left to right. Bicycle going down, negative slope. Bicycle going up, positive slope. Okay, students. So bicycle, ride the bicycle on this curve. Yes, you can drive. So where will you go? From left to right. So you're going down. So this slope is negative. Okay. Second thing, you see that here x is increasing. This is minus 3x, this is minus 2, this is minus 1. So moving in this direction, x is increasing, right? But fs is decreasing. So x is increasing but y is decreasing. That is why the slope is negative slope. Okay. Now what is the work done? Force into displacement. And I told you that it is the area between x-axis and this graph. So here also, students, we have a graph. Why not? So here in this portion also we have the work done, and you can see this work done above x-axis, so this is positive work done, and this is this area between the fs and x is of course the work done, and that's also the potential energy stored, and that is again this area is the work done. So that's the work done. Okay, that's also the work done, and that is stored in the form of potential energy, that work done. So students, that's your area. So find the area. Find the area over here. Area is equals to half into base into height. Here we don't need integration. We can simply find it. By integration also you can find this area. Okay, you will get the same answer. If you want to integrate it also, you will get the same answer. You want to check it out, you can check it out also, students. Now that's equals to, so I need not to integrate it, but you can find it yourself. You will get the same answer. Half into what is your base? Base is xm. What is your height? This. What is this height? This is equals to fs is minus kx. So this is your height. So what is this? Minus kxm. So at xm, this is equals to minus kxm. Yes? Minus kxm. So what is this point? xm and minus kxm. Okay? So this is your base. And how do we find minus kx? Arey bhai, y is equals to f of x equal to minus k. So put the value of x here. xm. So put the value of, so half kxm. Simple. And that's equals to minus half kxm square. So that's your work done. That's your area. That's the potential energy stored. Okay. So work done is equals to minus kxm square. So but this spring force will always act in the direction of decreasing potential energy. So instead of writing here this u, it's better to write here what? minus delta U. Okay, this also work done is equals to minus delta U. This one is also minus this thing is. So this is minus delta U. And here also, students, it's work done is equals to minus delta U. Now we have this spring force is also conservative force, depends on the initial and final position, and if initial and final positions are same, then what is the work done? Means you stretch the spring and then came it back, you stretched it and came it back to this position. So initial and final position are same. So xf is also the same, xi is also, means both are x. So what is the work done? So work done by the spring force is equals to minus xi to xi. You have taken the spring this side and then back. So initial and final position is same, kx dx, and that's equals to k is constant outside, and this x dx is x square by 2 xi to xi, and that's equals to minus k into, put this value, xi square upon 2 minus xi square upon 2, so that's 0. So work done by the spring force is 0 because initial and final position is same. So students, that is why spring force is conservative force. So it depends on initial and final position. Now you have what you have done is you have taken this spring this side and now leave this spring. So what will happen? It will move this side, it will come here, but it is not going to stop here. Why? Here Fs is 0, it is equilibrium. So at equilibrium force is 0, but spring force is 0 here, but it has the momentum. So due to its inertia, it will move forward over here, and then again spring force start acting in this direction as it moves past here. So from here spring force again acting to bring it back to the equilibrium position. So again its speed will start decreasing, its velocity will start decreasing, and its velocity will 0 here, and again spring force will pull it back to the equilibrium position, but here its velocity is maximum and it has the inertia and it will still keep on moving, and but spring force is acting in this direction, so it will bring it back. Okay, so this way simple harmonic motion will be there, and let us draw the graph of this simple harmonic motion. So the graph is figure 6.8. So this graph has three energies: mechanical energy, kinetic energy, and potential energy. And this is your position, x-axis. So your position was from xm to minus xm. And you know that kinetic energy and potential, they are changing, but their sum for conservative force, their sum will always be the same at all the position. So let this be the curve of the, which is constant, mechanical energy. So this is the curve of mechanical energy, students, constant at all the positions. This is the graph of mechanical energy. Now let us draw the graph of potential energy. So at extreme, the potential energy was maximum. Yes, even over here the potential energy was maximum, and at equilibrium position there was no spring force, there was no potential energy. Potential energy was 0. So that's the curve of the potential energy. Now what is the curve of kinetic energy? So this is the curve of exactly, parabola. Both are parabola, but in opposite. So this is the curve of kinetic energy. So kinetic energy was 0 over here because it came to rest at extreme, and then when it was moving towards the mean position or the equilibrium, kinetic energy started increasing. So it depends on kinetic energy, depends on the velocity. So velocity was maximum at the mean position, and then again velocity start decreasing, kinetic energy start decreasing, and it is converting into potential energy. So kinetic energy start decreasing, potential start increasing. Here potential makes sense. Potential start decreasing and kinetic energy start increasing. So students, but their sum is constant. Now at any particular point, let this be x. Okay. What is the, let us write this equation, E is equals to k plus u. What is my target? I want to find the maximum velocity. See, this is what I need. What is the maximum velocity? Means, so maximum velocity will obviously at here, at this point you have this maximum velocity. Okay, so what is the maximum velocity? That's we need to find. What is the maximum potential energy here, students? What is potential? What is maximum potential energy? What is potential energy? Yes, potential energy of the spring force. So work done is equals to minus kxm square by 2, right? And that is equals to minus delta u. Okay, so this work done is, here the energy was 0, so all the energy stored here, so this will be the u, you can call it u because the initial is 0. Okay, so u is equals to half k xm square. So I know this value of maximum potential energy, but what is maximum kinetic energy? Maximum velocity over here. Let us find it out. So what is the kinetic energy, students? This, yes, come on. This is equals to maximum, we have just written half k xm square because here v is 0. V is 0, so the only energy is potential energy, and that is your kinetic energy. So at xm, k is equals to 0. So E is equals to U, and U is equals to half k xm square. So that's your potential energy, means kinetic energy, 0, and mechanical energy is this. So this mechanical energy, half k xm square. Now at any point x, so this is the point. So at this point, let this point be x. Okay, so what's the, so at this point, what is the kinetic energy, what is the potential energy? Kinetic energy will be half m v square, velocity at this point, plus what is the potential energy? Half k. So at xm it was xm, at x it was x only, x square, kx square. Now I need to find out Vm. So at Vm will be when x equals to 0. So at x equals to 0. So this will be x is equals to 0 here. So there is no potential energy, x equals to 0. So you have the equation half xm square is equals to half m v square. So half cancels out, and this Vm is equals to under the root k by m into xm, right? Square rooting both sides. सो xm का स्क्वायर हट जाएगा और इधर आ जाएगा स्क्वायर रूट एंड दिस k is there, m will come this side. So students, that is your maximum velocity at this point, at the mean position, at the equilibrium position. Now I want to do with you, this is, I know that this numerical will take time, and so students, you need to be with me with next 15 minutes. If any of you would go, then watch this video on the YouTube, okay? Okay. Now example 6.8. Very important, students. So to simulate car accidents, auto manufacturers study the collisions of moving cars with mounted spring of different spring constant. Consider typical simulation with a car of mass 1000 kg moving with a speed of 18 km per hour on a smooth road and colliding with a, so we have this spring. So very stiff spring it will be, definitely. Lot of K. K is very high. How much is the K here? See students, K is given 6.25 into 10 to the power 3 Newton per meter. So that's the K, quite high. So now the car is going to hit it. Okay, hit this spring. This is my car. This car is going to hit this spring. Okay. Now how much is the maximum compression? So this was 0 and this is xm. This is going to compress this spring. Okay. You need to tell the maximum compression. Now here, as you know that here it was possessing kinetic energy, and here that kinetic energy will be converted into potential energy. Here kinetic energy is 0. Here potential energy was 0 because at equilibrium this was potential energy was 0. So whole kinetic energy is converted into potential energy. So it means K equals to potential energy stored in the spring. This was kinetic energy of the car. So kinetic energy of the car is stored in the potential energy of the spring. Now what is kinetic energy of the car? Half m v square. So this was the velocity over here at this point of time. Let the velocity be v, and that is given to us. That is 18 km per hour. So 18 km per hour, 18 into, so 1000 upon 3600 second, so meter per second, and this comes out to be 5.18. So students, every time multiplied with 5.18, okay, no need to write it again. So 18 cancelled out, it's 5 meter per second. So that's the velocity. Now what is potential energy? That is the work done, and that's equals to K, half K xm square. Kinetic energy can never be negative, it is always positive kinetic energy. Again a hint. Okay. Now we need to find this xm. This is what we need to find. So this will cancels out. I know the value of m. That is so this spring is massless. Okay. What is the mass of the car? So this is the mass of the car. This is the velocity of the car. This spring constant. And this is m. M is this position, maximum compression up to this point. So what is mass of the car? That is given to us 1000 kg. So put these values over here, 1000 kg mks meter kilogram second into velocity is 5 meter per second, and that's equals to what is spring constant? 6.25 into 10 to the power 3 into xm square. 10 to the power 3, 10 to the power 3 cancels out, and this will be xm square is equals to 5 pound. Are we missing something here? Yes, this is 5 multiply 5 v square. So 5 multiply 5 upon 6.25. So remove this point from here and you will get 100. So 25 and 25 to the 6. This is 25, this 4. So xm is equals to 2, and this is meter. So students, xm is equals to 2 meters. Okay. Now the second part of this question. Here there were two assumptions that we had taken. What were the two assumptions? First one, massless spring. Second, coefficient of the friction was 0. That is, friction force was 0. Now, I want this, actually this, of course on this road there will be friction. So in the second case, which is your example 6.9, same question, but now with the friction. Now see the beauty of the concept. Here I have taken that E is equals to K plus U. Energy, mechanical energy is conserved. This I can only take when I have conservative force. Okay. Now, when only conservative force, when the work done is only by the conservative force, but now friction force is not conservative, so I cannot use this formula now. Okay. So now I have the friction. So again this car is going to hit this spring. Same question. So there will be friction force. So you have the forces. Spring force acting in this direction, that is equals to spring force is what? You have studied it. Minus kx. And what is the force of friction here? So both are acting in this direction, because the spring will be compressed after hitting it. So that's the direction of spring force and frictional force. Okay. Now, what is friction force? Friction force is U into N. What is N here? So normal reaction, that is, so gravitational force mg, and it is not moving vertically. So both the forces are equal. So that is equals to nu mg. Now, so student, this was your equilibrium position, and this spring is compressed by this car from here to here. The car has moved from this point to this point. This figure is there in your book also, figure 6.9. So this was your equilibrium position, and this is your xm, body is at this position from 0 to xm. So that is why at this position the spring force and friction force was also acting during this. So this is non-conservative force. This is conservative force, spring force. So here in this system, mechanical energy is not conserved. So you cannot use this formula that E is equals to K plus V, and that's equals to constant. No, they are not constant here. They are changing because we have a non-conservative force, friction over here. So sir, then what shall we do? You can use work energy theorem. So note, when there are non-conservative forces involved, in doing work, you will be using work energy theorem. Okay? So use the work energy theorem in this case. So what's work energy theorem? Work energy theorem is simply change in kinetic energy is equals to work done by all forces. Okay? Conservative, non-conservative, by all the forces. So what is kinetic energy? Final minus initial, and that's equals to, what's the work done? Work done by the spring force plus, because the work done by the, because this work done is in x direction only, in y direction there is no work, so these forces are exactly cancelling them out. So work, you can even write work done by the spring force, work done by the frictional force, plus work done by the gravitational force, plus work done by the normal force. Okay, but work done by the gravitational force is 0, work done by the normal force is 0. Okay, why? Because the angle between the displacement, there is no displacement in the direction of these forces in y direction, the only displacement is in x direction. So the angle between the displacement, so this was your normal, this was your mg, so for both of them the angle is 90 degrees. So that is why work done by gravitational force, and this is 0 because the angle was 90 degree, right? So the only work done by was by the spring force and the friction force. Now what was final kinetic energy? The body was stopped at xm, and what is initial kinetic energy? Half mv square. And what was the work done by the spring force? Minus k xm square. What is the work done by frictional force? So that's also negative. Why? Why this is negative? Students, I told you I want the net answer to be negative. So this net is negative. Why? Because spring force is acting in, this is a displacement, and spring force was acting in this direction, and frictional force was also acting. So this is a spring force was acting in this direction, and frictional force was acting opposite. So both are acting up in opposite direction. So the angle was theta is 184, both of them. So that is why the work will be negative. So xm ka square, so doesn't matter, squaring it positive, k is positive, so this number will be negative. This is what I want, 180 degree. Now the force of friction, nu mg, right? So m and g are positive, mu is positive, so this will be this into displacement, that is xm. So force into displacement, right? So here the force was minus, force was kx m, half kxm into so students, the work done by the spring force is minus 2 kxm, and work done by the friction forces, this is the frictional force, and this is your displacement. Okay, let us finish it. So this will be equals to, so half multiplying both sides with 2, so what do we get? mv square, in multiplying both sides with minus 2, okay, so this negative sign will also be removed, and that's equals to kxm square plus 2 mu mg xm. Now I want to find the value of xm, right? This is what I want. So this xm, see this equation is quadratic in essence. This xm square, this is xm, right? So xm square plus 2 mu mg xm minus mv square is equals to 0. So this is something like y, isn't it? So y, ky square plus 2 mu mgy minus mv square is equals to, this is something like ay square plus by plus c is equals to 0, isn't it? And how to solve this quadratic equation? What is the quadratic formula? That is y is equals to, or it can be x also. So minus, yes, minus b plus minus under the root b square minus 4ac upon 2a. So that's the formula here, students. So what is a here? So here you will get xm. So xm is equals to minus b. So what is b here? So this is your b, this is your a, and this is your, this whole is your negative, along with negative is your c. Okay, So xm is equals to minus b minus 2 mu mg plus minus under the root b square means 2 square mu square m square g square minus 4 ac, so a is k and c is minus mv square divided by 2a, so 2 into k, and as xm is positive, so we are not going to take this negative sign because negative will be negative, but xm is positive, so therefore I am not taking this negative sign. Okay, so as xm is positive, therefore xm is equals to, now this 2 will also be cancelled because this is 2 square, so 2 square, and this is also 4 is also 2 square, so 2 square common, so comes out as 2, so this 2 and this 2, they will all be cancelled out. So what do I get? Minus mu mg, xm is equals to minus mu mg plus under the root mu square m square g square plus m k v square. So minus is plus divided by k. So put all the values and you get xm is equals to plus 1.35 m. So students, this I have taken this direction xm as positive direction, so that is why I have ignored this negative sign. Negative will be negative, so I don't want that. So thank you so much for being with me today.